With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone. So let's see this question. In this question it is given that calculate the freezing point of a solution of a non-volatile solute in unknown solvent of molar mass 30 gram per mole. So the molar mass of solvent is given and mole fraction of solvent is given 0.8. Given that the latent heat of fusion is given 2.7 kilocalorie mole inverse and freezing point of solvent is given 27 degrees centigrade and the value of R is 2 calorie mole inverse Kelvin inverse. So first of all, what you need to calculate? We need to calculate the value of Kf. So the value of Kf, that is the freezing constant, is given by this formula m into R into Tf square whole divided by 1000 into delta Hf, that is heat of fusion. So now let's substitute the values which is given to us. So the value of m is what? M is the molar mass of solvent. So we have been given the molar mass of solvent is 30 gram. So it is 30 into what is the value of R given to us? It is given 2 calorie mole inverse in terms of calories and TF square. So what is TF? TF will be, you can see very well, the freezing point is given 27 degrees centigrade. So in terms of Kelvin it will be 273 plus 27 which is equals to 300 Kelvin. So which is equals to 300 into 300. This is the whole value. This will be divided by 1000 into what is the value of delta HF? The value of delta HF, that is the heat of fusion, is 2.7 kilocalorie mole inverse, or you can say it is 2700, right? So this is the entire value. Now when you will calculate, this value will come out to be around 2. This value will come out to be 2. So value of Kf is 2 Kelvin kg mole inverse. This is the unit. So this is very important, that the value of Kf will come out to be 2. Now, what is our aim? Our aim is to calculate the depression in freezing point. So for calculating the depression in freezing point, first let's see what all things are required. So you know very well that depression in freezing point is equals to Kf into small m. What is small m? Small m is molality of solution, right? Molality of solution, which is given by, we know that small m, that is molality of solution, is nothing but number of moles of solute in divided by weight of solvent in kg. This is only molality, right? Number of moles of solute divided by weight of solvent in kg. Now what is given to us? We have been given that mole fraction of solvent is 0.8. This is given to us. So if mole fraction of solvent is given 0.8, then you can say very well that mole fraction of solute will be equals to 1 minus 0.8, because the total mole fraction is always 1. So it is 0.2. So from here what you can say that the mole fraction of solvent is 0.8 and the mole fraction of solute is 0.2. So what is the ratio of this mole fraction is going to give us? So you know very well that mole fraction of solute will be equals to the number of moles of solute divided by the number of moles of solute plus number of moles of solvent, right? And mole fraction of solvent, if you will calculate, mole fraction of solvent, if you will say, it is equals to number of moles of solvent divided by number of moles of solute plus number of moles of solvent, right? Now, so in this way, what you need to write down, the ratio of mole fraction of solute to mole fraction of solvent is going to give you what it is going to give you, the ratio of mole fraction of solute to mole fraction of solvent. So if you will say the mole fraction of solute divided by the mole fraction of solvent, this is equals to the ratio of mole fraction of solute to mole fraction of solvent is going to give you number of moles of solute divided by number of moles of solvent, right? This is very important. The ratio is going to give you number of moles of solvent. And what was the ratio? The mole fraction of solute was 0.2, right? And the mole fraction of solvent was 0.8. So this ratio will come out to be 1 by 4, right? So you know very well the number of moles of solute can be written as weight of solute, right, divided by the molecular mass of solute, and then number of moles of solvent can be written as weight of solvent into molecular mass of solvent, right? This is what you can write down, the number of moles of solute by number of moles of solvent, and this value is equals to 1 by 4. Now we have been given that the molecular mass of solvent is 30, right? So if molecular mass of solvent is given 30, now so let's write down substituting weight of solute divided by molecular mass of solute into weight of solvent, that is equals to 1 by 4 into 30, right? So this is what you need to remember. Now we have already discussed that molality is equals to number of moles of solute by weight of solvent. So you can say number of moles of solute means weight of solute divided by molecular mass of solute, right? And what is weight of solvent? So let's say it is weight of solvent, but since it was in kg, you need to convert it into gram. So you can multiply 1000 in the numerator, because the weight of solvent need to be in kg. So for converting it into gram, you can multiply the numerator by 1000. Now you can see very well that we have got the value of weight of solute. We have got this value, that is weight of solute by molecular mass of solute into weight of solvent. So this value we have just find out as 1 by 4 into 30. So you can say that molality is equals to weight of solute into 1000, just now we discussed, divided by molecular mass of solute into weight of solvent in grams. So from here you will write down 1000 divided by 4 into 30 is molality. Now your aim is to calculate the value of delta TF, that is depression in freezing point, which is KF into molality. So you know the value of KF has come out to be 2, and the molality 1000 divided by 4 into 30. So from here the value of delta TF will come out to be around 16.67 degrees centigrade. So this is the depression in freezing point. So what will be the freezing point? The freezing point will be, this is the depression, delta TF is depression freezing point. So freezing point will be the actual freezing point. So freezing point will be the freezing point actual minus delta TF, that is you need to depress the actual freezing point by delta TF. So you will write the actual freezing point was 27 degrees centigrade minus 16.7 degrees centigrade, which will come out to be 10.33 degrees centigrade, and this is only the required answer for the given question. I hope you have understood. Thank you very much.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.